students. This is the 8th lecture of telemetry principle and we are going through the unit 2nd, and unit 2nd is multiplex system. Basically, when we are talking about multiplex system, what is multiplex system? Actually, multiplex system is a combination of multiplexing plus modulation. When we want to transfer any data in telemetry system from transmitting side to receiver side, actually we have to perform some operations on that data. As the data coming from the sensors is basically of low voltage, that is why that voltage has to be increased at the transmitter side. Also the frequency of that signal is also very low, and to send that particular low frequency signal to distant place we required modulation. Now between transmitter and receiver only a single channel is there, but at the transmitter side as well as at the receiver side we have various users or various sensors or the various transducers. As we are taking an example of a particular power generation unit, at the power generation unit or hydro power generation unit, you have to take many datas, many data as pressure, flow, temperature, wheel speed and all the things. But all that data is going to be collected by a single unit. That single unit is directly connected to the remote location or the remote place where the next substation is established to monitor the complete hydropower station, and a link is made between these two positions. It means at the command and controlling center we are getting that data through a single line, whether that data is of various sensors. So it means we have n numbers of sensors, they are using a single channel between transmitter and receiver. That is why multiplexing is required, and combinedly this multiplexing and modulation is known as multiplexed system, and that is your second unit. In the previous chapter or the previous lecture, we discussed the multiplexing introduction, how multiplexing has to be done, why the multiplexing is required. In this particular unit or sorry in this particular lecture, we are going to basically concentrate on types of multiplexing. I told you in the previous that frequency division multiplexing is used for the analog signals, whether the time division multiplexing is used for digital signals. So starting from the frequency division multiplexing, what is going to happen in the frequency division multiplexing? Actually, if we are having x megahertz frequency bandwidth, then we are going to divide this x megahertz to n number of users by simply dividing it into divided by n. It means the available frequency spectrum of the channel is divided among the multiple logical channels. It means the each user can have access to its own assigned frequency or logical channel at all the time that the individual user is active. In this example, you can see that we have 3 users at the transmitter side, 3 users at the receiver side, but the channel is one only, the path is only one. That path I am taking as an example that path is of 300 megahertz. So, what is going to be happen? That 300 megahertz is divided into 3 logical channels of 100 megahertz each, channel 1, channel 2, channel 3. And these 3 channels is going to be utilized by individual users for complete time, but the available bandwidth for a single user is only 100 megahertz. So, there are some key points of frequency division multiplexing, and that points are that it is a analog technique. In this technique, signals of different frequencies are combined into a composite signal and then transmitted on a single link. It means I am getting the data from user 1, 2, 3, we are going to combine that signal and making a composite signal by it, and that composite signal combined using the combined bandwidth of various channels. Also, each signal have different frequencies and the channels are separated by the strip of unused bandwidth called guard band. Basically, what is that? I am going to tell you. You all are very much aware about the interference word. Interference. Actually, when we are going to divide a single channel between 3 users, then what is going to happen? If it is a 300 megahertz signal which is situated between 400 megahertz to 700 megahertz, we are going to use 400 to 500 megahertz for user 1, 500 to 600 megahertz for user 2 and 600 to 700 for user 3. But in this condition, you have to design the complete system so precisely that starting from the just 501 to 600, complete bandwidth is available to user 2, and as well as frequency is going to increase from 600 to 601, that is used for the user 3. But practically it is not possible due to ACI. What is that ACI? Basically that ACI is adjacent channel interference. It means if 2 channels are just adjacent to each other, there is a chance of frequency interference between them. So, how it can be avoided? To avoid this type of condition, we are going to make a guard band, or we can say that a strip of unused bandwidth. How is it is going to be made? If we are using that 500 to 600 bandwidth, what we are going to do, from 500 to 505 megahertz and in this side 595 megahertz to 600, we are just leaving a strip of 5 megahertz idle. By leaving it idle, what is going to be happen? Actually, that idle bandwidth helps us to prevent the overlapping of adjacent signal. It means in frequency division multiplexing, as far as we have a advantage that our all users can use the channel simultaneously at the same time, but there is a limitation in bandwidth, as some bandwidth is allotted to guard band and some is divided between the users. So, this is a disadvantage of frequency division multiplexing. So, what is going to happen in frequency division multiplexing? That it sends the signal in several distinct frequency range. As you all know that if we are getting a voice data and that voice data is 2 to 20 kilohertz audio signal. So, for the transmission it is required that these voice signals are going to be modulate for the transmission purpose. So, each signal is modulated on the different carrier frequency which are separated by guard bands. This is showing the arrangement of time and frequency allocation of the multiplexing part. You can see it here, this is the time part, this is the channel frequency which is divided between 6 channels. So, when we are talking about the FDM system transmitter, you can easily see here, we have here various analog signal M1T, M2T, MNT. These all signal are modulated with the subcarrier modulated of with a various subcarrier frequencies. Their frequencies are F1, F2, Fn. By this modulation, we are going to get this S1T composite signal, combined signal, S2T modulated signal, SNT modulated signal for the user 1, 2 and N. In this modulation scheme, we are getting the frequency translated signal from M1T to S1T, because this is the voice or data signal having low frequency, whether for transmission we required high frequency. So, a high frequency or high frequency subcarrier signal is modulated with this low frequency signal and we get that S1T, S2T, SNT. Then these all signal are going to combinedly make a composite signal that is called MBT, and that composite signal is going to be transferred on a single channel and that is called FDM signal. Also, the transmitter part is using a common carrier frequency that is called FC, which is aligned with the available channel bandwidth. If our channel bandwidth is between megahertz, then particular this part is going to use this composite signal. Here this particular diagram is showing the frequency spectrum of the composite baseband modulating signal. You can easily see that it is having F1, F2, Fn with the bandwidth of B1, B2, Bn, and the combined bandwidth of FDM signal is capital B. So, this is about the FDM system transmitter. Then FDM system transmission description, that is the same discussion that I already discussed, that in FDM each user is assigned non overlapping frequency ranges so that multiple signals can be transmitted at the same time. Multiple messages signal M1T, M2T, MNT from multiple source are modulated over different subcarrier frequencies with F1, F2, Fn, and same them to a adder. The adder gives us the composite signal, and that output composite signal is modulated over a carrier frequency of Fc and transmitted over the channel. Similarly, at the receiver side we are having a FDM system receiver, as at the transmitter side we are going to use a Fc carrier frequency for the composite and F1, F2, Fn sub carrier frequency for the various user. We are going to make the same arrangement or the coherent detection at the receiver side. We are getting this FDM signal, the main receiver is locally generating this Fc carrier frequency to demodulate the composite signal. This is the composite baseband signal MBT. That MBT is going to apply to various band pass filter, so that F1t, F2t, Fnt signals can be separated. After separating these F1, F2, Fn signals, we are performing the sub carrier demodulation by using demodulator F1, F2, Fn, and we are getting the baseband signal or recovering back the baseband signal at the receiver side. So, this is about the FDM system. So, these are now we will discuss the basic disadvantages, because as I told you FDM have many disadvantages. That is why in these days FDM is not going to be used popularly. In FDM actually we are using guard band, in which the complete band is some part of the band is allocated to just unused frequency range, so that adjacent channel interference can be avoided. Also the particular user is getting the share of the available channel, it means the available bandwidth is also decreased, it means capacity of the channel is also decreased. It means the main disadvantages of FDM systems are that the problem with FDM is that it cannot utilize the full capacity of the system, because the main bandwidth is divided into various users including the guard band. Also we need to assure that the adjacent band do not overlap each other, otherwise the signal in one band may interfere with the signal in the other. Also although the system has the capacity, still in some cases the channel cannot pass the actual signal, because when we are dividing the actual channel bandwidth into the various user, sometime it is going to happen. So, these disadvantages of FDM signal leads to the next type of the modulation multiplexing scheme, and that is TDM, time division multiplexing. What is going to be happen in time division multiplexing? In time division multiplexing actually the complete channel is going to be used in slots. You can see in your data in your mobile, when you are switching on the internet and switching off the internet, you are getting sometimes a message that packet switching is on, packet switching is off. That packet switching is basically termed from this time division multiplexing. Actually in time division multiplexing, what we are going to be do that in a particular time division multiplexing part, we are going to make a packet. If there are n number of users, then this a single packet having the share of n users, means this particular packet is defined in term of time. Let we are taking a time slot of 4 seconds. It means we are using 4 users, a 500 or 600 megahertz channel for the transmission, and that 500 megahertz channel is going to be utilized by 4 users by this packet transmission technique or the time division multiplexing technique, that this particular packet of 4 second is divided into 4 parts of 1 second each. It means this 500 megahertz bandwidth is allocated to first user for complete 1 second. After 3 second, again when one frame or one slot is transmitted, again the user 1 will get the chance to send its data. It means in time division multiplexing, we are creating the packets of data, we are loading that data on a particular time slot of the available time frame, and then that after the sending one frame, we are going to send the next frame. So, in time division multiplexing, you can easily understand one point: time synchronization plays an important role, because time management, time synchronization is very much required for this purpose, because you have to monitor the time slot of the frame and the slots of the various users. If time synchronization breaks, it means the data will be lost. So, what is going to happen in time division multiplexing? In time division multiplexing, the time is divided into multiple smaller units called slots, and each user is given a slot to transmit the signal. It means you remove the last disadvantage of FDM signal, that signal can the user cannot use the full capacity of the system. In this part, the system can use the full capacity of the channel, but in slots. Each user has the entire bandwidth of the channel for a short interval of time. It means transmission is also increased. So, these are some descriptive points of the time division multiplexing. You have to understand all these. As FDM was an analog scheme, time division multiplexing is a digital multiplexing scheme. In this particular scheme, channel length is not divided on the basis of frequency, but it is divided on the basis of time. Also, the total time available in the channel is divided between the several users. Then each user is allotted a particular time interval, that is called time slot or the time slice. Then in TDM, the data rate capacity of the transmission medium should be greater than the data rate required by the sending of receiving device. Also, the clock synchronization is one of the major issue in TDM system, as a small mismatch in the timing may ruin the utility of overall system, that I already told you, that time synchronization, because you are going to transfer the data in the time synchronization mode, time mode. If any time mismatch is there, any user can lost its turn or lost its slot, that will be resulted in the form of particular capacity loss. So, this is the diagrammatically representation of the time division multiplexing. The same users 1, 2, 3, 4 are using the same bandwidth for a limited time, as if it is a, for example, this is 4 second, 1 second for each user. Then this is the about time division multiplexing. So, when we are talking about time division multiplexing, this is also possible of two type, synchronous and asynchronous. It means in synchronous the time slot of equal range 1 second, 1 second, 1 second, but asynchronous time slot of various timings, that we will going to discuss in the next particular lecture of the telemetry systems. Till then, thank you.